All right, this is Chapter 9.1 notes. Chapter 9 is all about data analysis and how to display data. So that's kind of where we're heading in Chapter 9. But 9.1 is all about scatter plots. So a scatter plot is a graph that shows the relationship between two data sets. Okay, so the two sets of data are graphed as ordered pairs in the coordinate plane. Okay, so our example 1, the scatter plot at right shows the amount of fat in grams, that's on our x-axis, and the number of calories in 12 restaurant sandwiches. So there's 12 different representations of restaurant sandwiches. Okay, so example A says how many calories are in the sandwich that contains 17 grams of fat. So you go over to grams of fat right here between 15 and 20 is 17, and you go up right here. And then to figure out how many calories, you just go over. So there are 400, yes, that was the bell, calories. Part B says, how many grams of fat are in the sandwich that contains 600 calories? Okay, so I'm going to go over from 600. And when I hit that dot, I go down. And I see that there are 30 grams of fat. And part C said, what tends to happen to the number of calories as the number of grams of fat go up, and as grams of fat increase, calories also increase. Okay, that's about it for scatter plots. They are not too complicated. Okay, so the on your own says, what if a sandwich has 650 calories based on the scatter plot in example 1? How many grams of fat would you expect the sandwich to have? Okay, so 650 calories. Here's our 650 line. Okay, so how many calories would I expect to have? Well, this dot right here is really close, or how many grams of fat, and I would say that's about 33. So maybe one more. I would say about 34 or 35 grams of fat. That would be my estimate. And I use the graph to help me determine that answer. And these are very important relationships to talk about. So a scatter plot can show a relationship exists between two sets of data. So when x increases, y increases, this is a positive linear relationship. When x increases and y decreases, you have a negative linear relationship. Linear meaning there kind of looks like a line. Okay? A nonlinear relationship, the points, lie in the shape of a curve. Okay, so that's a nonlinear relationship. And then when the points look like they have no rhyme or reason to where they are plotted, there is no relationship in the data. So, example 2, identifying relationships. It says describe the relationship between the data, identify any outliers, gaps, or clusters. Okay, an outlier is something that just seems like it doesn't belong. And I will write that to help us remember. So it doesn't belong. A gap I would consider to be defined a big hole in the data. So right around here, I would consider that a rather large hole in the data. So a gap is a hole in data. And a cluster, when you think of a cluster, you think of a lot of data points in one spot. So that is what a cluster is. So this relationship, as x increases, it appears that y increases as well. So this is a positive linear relationship. I would consider this to be an outlier, this point right here. So I'm going to call that 70, and let's call it 2250 is the outlier. And I would consider right here to be a gap. Okay, so there's a gap in the data from 500 to $1,500. And I would consider there to be a cluster right around $500. Okay, and part B, this one appears there is just no rhyme and reason between the person's age and the number of pets they own. So I would say this has no relationship. And when it has no relationship, you don't worry about gaps, clusters, or holes in the data. And the on your own, wouldn't that be helpful if I gave you the data? So I'm going to pause it and write this data and then hit play here in a second. Hold on. All right, sorry about that. Take a second to copy this down. If you need to hit pause, go ahead and do so. And the directions say to sketch a graph. So I'm going to give you the basic outline, and then we're going to talk about the answers to this one in class. Okay, so when I say sketch, I mean label your axis. So this is going to be study time, and this is going to be test score. Okay, and then go from 0 to 100 here. And over on your x-axis, you're going to have to go to 120. Okay, and then you're just going to dot wherever these points. So if I had 30, 80, just estimating here, I would go 30, 80, make a dot. It really doesn't have to be anything fancier than that. You don't need to draw the lines in the graph. I would like you to label the whole axis though. Okay, so do that, and we will talk about whether that has any outliers, any clusters, any gaps in class. So see you tomorrow.